Not me. It's a set I chose you, but.
No, it's okay.
Well, that was a couple months ago.
I said you made math fun for me.
I know, that was,
Don't
you're so precious.
make it so weird.
Tabby, like, you just made math fun, I should have.
Anyway, that really made me like chuckle. And I was like, he's serious. He is serious. That's all right. I love him for it. He's such a nice kid. All right. Derivatives of natural logs. You ready? If you remember the E's, it's going to be just as fun. Just as fun. All right. ddx. What that means, again, is the derivative of ln of x. So we'll just start it with really easy one. If you see an ln and then something after it, to take the derivative of it, all you have to do is 1 over x. Oh, super easy. But it's not always going to be an x, right? It might be x squared, it might be 5x. So what if it was the ln of, we'll call it u, like a u thing?
What's the D? What's the DX?
Just already said that. It means derivative.
Okay.
Okay, so what do you think I would write here then?
1 over U.
1 over u, but what would I have to attach? The chain. Okay, so some books would actually write it as u prime over u. Okay. So this is all you have to remember. If you're taking the derivative of an ln, whatever comes after it, you just write 1 over it and then multiply by its derivative underneath. Okay, so let's do a few examples. Find the derivative.
Why do they write so many different ways to just take it to say like?
Because there's so many different ways. I mean, we haven't even done the trig ones yet.
Yeah, but why do they always have to have a different thing in the beginning? Because it's a different way of doing it.
There's not. But
Okay, I've
Yeah,
never
I
seen
feel like
the
we
D
never
and the
used that
DX.
first one.
I did. I used it on E. Look in your E notes.
No, but like.
But like, it's so mean.
It's never like.
Okay, and there's just
Actually, LNX.
there's just multiple ways of writing it. I'm sorry that it upsets you.
Mathematicians are mean.
That's what it is.
Yeah, but they're saying it's the same thing.
It is the same thing.
Yeah, but then why do you just have one?
Well, like,
Is that
look,
universal?
Oh my gosh. All right, here we go. Find the derivative of ln of 5x squared. Okay, so the derivative, there's another way of writing derivative, by the way,
What is that?
prime of x. So what would it be? What would you write?
1 over 5x squared.
1 over 5x squared, and what would you multiply that by?
10.
10x. Okay, now you do need to clean this up. So 10x would be actually on top.
Oh,
And reduce the fraction, what would be the final answer?
2 over 1.
2 over x. Okay? That is the derivative. All right, let's do this one. Derivative of ln of 2x squared plus 4. So that would be, again, what would it be? 1 over 2x squared plus 4. And then what do I need to multiply by after that?
4x.
The derivative of 2x squared plus 4, which is 4x. So it would be 4x over 2x squared plus 4. Can you reduce that anymore?
you're gonna take it to now.
You can take a 2 out. Correct, Jack? Everything has a 2. I can take out a 2 then. So the final answer would be 2x over x squared plus 2. Yeah. You can
Trick question.
Trick question. I know. You're all like, no. Oh.
The x's, that's what, yeah.
All right. Now, those, of course, were your easier ones. Let's do some fun ones because you.
Outrage.
Oh, really?
And by the way, for my SPCC people, when you actually take your derivative test, I'm being nice to you here. I just want to let you know that after the ln probably will never be an x. It will always be a quantity. But let's move away from that. What am I going to do here? What am I going to do here?
You have to put it back on top.
Can't.
The
Although
product.
I give you, muy bien, Jack, but Jed, I'll give you props for saying that. a lot of students were like, well, why couldn't I move this up here and then take the derivative? And then you could write it as 1 over x to the x squared, but don't you think that looks weird? And then multiply it by the derivative of that and then try to clean it up. Don't do that, okay? So I'm proud of you for thinking that. We are gonna show you where that will work. But yes, we want to do a product rule. It's a product after all. So let's do the product rule. First times derivative of my second, which is what? What's derivative? 1 over x, plus the second, which you just leave it as ln x, times what's the derivative of the first?
2x.
Okay, I want to talk about something in a minute. Can this reduce? Can you clean up this first portion to just x? Listen to me. Am I allowed to multiply these two together, yes or no? No. The ln and what comes after it are inseparable unless you do unless it's got a multiplication of something. But you are not taking the ln of this. So what I would suggest you do is put this in the front. So rewrite plus 2x ln x, okay? Do not call this 2x squared. No, it's not 2x squared. It's just the ln of x. Now, what could you do here? You could factor out an x. So this is one way of writing it. I'd let you keep it like that. If you want to write it another way, you could write it as 1 plus 2 ln x with the x on the outside. Either way is fine. That's a pretty good one.
Wait, technically, wouldn't it be ln x squared then?
But it's not.
Because you don't.
You mean the 2x here?
No. The last x, it just stays the same even though they take an x out, with the ln x.
Here?
Yeah.
Yeah, but this x would go to the 2 in front of with the 2.
How do we know it doesn't apply to that?
Because you can't, it doesn't. You're not allowed to. ln x is its own thing. It's like
I run it as a different grade.
you can't, yeah, sure, go ahead. That's not going to help you. All right, this one is a quotient rule. So let's do this one. I'll talk you through it. You always need to remember these. Denominator times derivative of the numerator, which would be minus numerator times derivative of the denominator, which would be 3x squared, over the denominator squared, which is x to the what power? 6. It's x cubed squared. All right, so let's clean this up. So this would be x squared, yes? Minus, I want to put the 3x squared in the front, so minus 3x squared ln x over x to the 6th. Am I allowed to reduce x's?
Yeah.
I can. I'm just not allowed to reduce that one because that one is its own thing. ln x, its own thing. Okay? But x squared, and then x to the 6th will reduce to a 1, a 3 ln x, and then what would be left on the bottom? X to the, there you go. Yes or no? How are you feeling?
Wait.
I'm waiting.
Yeah. I can use it. That's all
All right. Now there's one thing about ln's and logs that sometimes differentiating. Sometimes you want to actually rewrite them before you differentiate. Remember when we first learned derivatives and we take a polynomial and we'd actually multiply it out because taking the derivatives sometimes of each one separately is easier? It's the same way with logs. Making it look like log after log after log is actually much easier to take a derivative of. So there's this one, and then we'll do this one. That one, okay? So yes, you could follow the rules and go 1 over this times the exponent times this, but that's a chain rule with a u, and it's just not worth it, okay? So what you could do here instead is rewrite this log as what? How would you rewrite it doing the properties we just learned? Right, it would be ln of x plus 1 to the 1/2, and then take that 1/2 and bring it to the front. So 1/2 ln x plus 1. Now that you rewrote that, now take the derivative of that. And it makes it much easier because the constant in front, you just tag it along with the derivative. And then how do you write the derivative of ln of x plus 1? It would just be what?
1 over x.
1 over x plus 1 times its chain, which is 1. I mean, if you want to put a 1 there, that's fine. So how do you write this now? 1 over 2x plus 2. That's much easier than if you had done it the other way. It just would be looking really messy, and it would be a lot of cleaning up to do. All right? So let me show you again on this one. Okay, so let's rewrite this before taking a derivative of it. So you have a product. What are you going to write it out then as? How do you expand this? Expand ln x plus 2 ln x squared plus 1. Do you all agree to that? All I did was rewrite it. Whenever you're multiplying inside of an ln, you can actually separate it by addition, okay? So that's the rule you missed on Friday. Anytime you're multiplying inside of an ln, you can separate it with a plus. The power comes in front here. All right, so now let's take a derivative of each one of these separately. What's the derivative of ln x? 1 over x, easy. Plus 2 will stay 2, and take the derivative of this. What would the derivative of ln x squared plus 1 be? 1 over x squared plus 1 times its chain, times 2x. So I do want this part cleaned up. This will become, again, think of this as being over 1, this is being over 1, so this would be 4x over x squared plus 1 over x. I will let you leave it like that. I will say I'm not quite sure if she wants you to rewrite it. She might make you rewrite this as one fraction. You should all know how to do this as one fraction, though. You just multiply those two denominators and crisscross. So x squared plus 1 plus 4x squared. So 5x squared plus 1 over x times x squared plus 1. That's another way of writing it. But I will let you keep it like that for now. Yes, no, maybe so. How are you feeling so far? Great. Oh, yay, we're almost done. Holy cow.
All right.
Okay.
Okay.
So, yeah, this is a quickie. All right, so evaluate logs without a calculator. And you will be required to do this without a calculator. I will give you a few of these, and they will be all ones that you should know how to do. So like log base 2 of 8 and log base 10 of 1 over 1,000. And I know you all know how to use it on the calculator with the log base button, but you're not allowed to. Okay, you actually have to show me how to do it without a calculator. Meaning what, Ms. Aceta? Well, here's the big hint. Set equal to x and zoop. I just love saying that. So here's what I mean. Set it equal to x and go like this. Zoop, and rewrite that for me. What would that be? 2 to the x equals 8. Can you make 8 a base 2?
Yes.
2 to the what? So guess what x equals? 3. So log base 2 of 8 is actually 3. And for those of you who don't remember, if you go to your calculator and you hit math, you can check the homework tonight and then go up to where it says log base. And the calculator is beautiful. Look at this. It actually gives it to you. You can write 2, you can write in, 8 here, and then your answer is 3. But I'm going to require this on the test, or else you will not be giving any credit whatsoever. So let's do this one right here. Set equal to x. Zoop. What would that be? Equals 1 over 1,000, which is 10 to the negative 3. So guess what x equals? Negative 3. Okay. And then last but not least, I will allow a calculator, but more specifically a scientific calculator for this section. Evaluate logs with calculator using change of base formula. This is when Mr. Wooten came in to observe my class one time. And I had just taught them change and base formula. And then Mr. Wooten even said, hey, so did you guys all remember what the change of base formula? This is to observe me. And they're like, no, we have no idea what that is. And that was John's class. And I was like, thanks, John.
And you're
I was
like,
like, we just learned it the other day. And they're like, oh, that's what that's called. I was like, I'm going to kill you all.
it's kind of hard to remember math stuff.
I know, I guess. But he was like, it's okay. It's okay. It was just- he understood. They don't remember the title. He does. All right. So change of base formula, for those who don't remember, is the coolest formula ever, especially when you aren't allowed this. It's the coolest formula. If you are not allowed a calculator, there is a formula that says log of base b of anything, a, whatever, 3, 5, 7, can be rewritten in any different base that you want. Log base c of a divided by log base c of b. Okay, now where did that c come from? Well, I'm going to show you what I mean in a minute. And this is my last example, by the way. So if you had log base 2 of 17, okay, obviously 2 to the x equals 17. What's the power of 2? I mean, that's tough right now. It's going to be a decimal, right? It's going to be like anywhere between, a little bit higher than 4, right? Because 2 to the 4th is 16. So it'd be 4 point something is what I know it's going to be. But what you're allowed to do is you're allowed to change the base. Meaning, on your calculator, on most calculators, actually even on your phone, which I showed the other group, they didn't know that this existed on their phone. Let me show you something. Turn your phone to the side. Come on. Your calculator has log of base 10. Most scientific calculators have logs in them. Those are not scientific. Those are just regular 4-function really ones. But what you could do then for this question is say, hey, the change of base formula says that I can take log base 10 of the big number, 17, and divide that by log base 10 of the little number 2. Little as in, yes, as in size. And again, so you can like go to this button right here, log, and do log 17 divided by log 2. And look at that. 4.08. We were about right. 4.1.
Let's go.
Why don't you just crossed out the log 10s?
They don't cross out. They have to be the same log. Let me show you something else.
Oh,
You could have actually done, ln. Why can you do ln?
they're the same thing.
Because it's a base e. So you could have chosen ln of 17 divided by ln of 2.
No.
Same answer.
Do we want to just do 10 every time?
I would actually tell you to do ln every time.
Oh, no.
ln is almost your universal one because it can get rid of e's also.
Why can't log do that?
Log only gets rid of base 10s or does with base 10s. That's its only job.
That's the question.
Because e's are in other things. All right, that's it. So now we know how to take a derivative. Now we can evaluate a log and change base. Here's your homework for tonight. It's only 11 problems. It's 11.
Plus last night's homework,
Last night's was only 20.
so 31.
You can do it.
I'm doing that.
I feel full confidence in you, honey.
Dude.